All right, let's look at it at an example, and we'll try to make this example have some visualization for ourselves here. I'm going to start with the examples in the book, and then I'll pull a couple out of the exercises. We will want to do a lot of examples of these. So, example one in the textbook, we're going to look at. We're going to have the function z is equal to some function in x and y. That's defined by being 3 minus x minus y. And we're going to look at the volume of a prism whose base is the triangle in the xy plane, bounded by the x-axis, the lines y equals x, and x equals 1. So we want the volume of a prism. Whoops, not a prism, but a prism. With a triangular base which is defined by the boundaries in the xy plane. That we have the x-axis is one boundary. We have x equals 1 is the other boundary, and y equals x is the third boundary. So altogether, this surface and this triangle makes our figure. Let's draw this out by hand a little bit here. Let's see here. I'll get my axes. So there's Z. Give myself some room. So there's my x-axis, my y-axis, and my z-axis. And if we note on 0, 0, this plane is going to be at 3. So that's going to be one slice we have. And if we think of the coefficients of our plane, it's going to be pointing downwards in x. Let's see, if we look at this plane, it should be cutting down. It should be going negative in x, negative in y, as it slices. So there should be a downward slice to this. But let's look at the boundary in the plane first. So I want to be up at x equals 1. I want to have the x-axis itself as a boundary. And I'm going to have x equals 1 as a boundary. So I'll just continue that boundary out. So there's y equals 0, which is the x-axis. And there's x equals 1. Then in the other boundary is the line y equals x, which is the identity function, which cuts our plane in half. And so this is y equals x. And so our prism is kind of constrained by this triangular base here. Let's see how good my drawing skills have gotten here. Let's see if I can. There. So that's the base, and we're having some prism that extends upward. So the thing we tend to have to worry about then with this prism extending upwards is the plane that's defined by 3 minus x minus y. And just a rough looking at the plane, because of its vectors being negative 1 in x and negative 1 in y. So let's see, if I come over here and I'm at 1 in x, then if I and be 0 in y, then this is going to rise to a height of 2. So I'll come over here, 1 in x, 0 in 2, right? All right, because if I'm at 1 in x and 0 in y, then this is 2. And if I come over here, I'm at 1 in x and 1 in y, so this is going to rise to a 1. And that should be all the points I need to kind of draw how this plane is slicing through. Right? We kind of, and that's what this boundary is doing, is it's saying if I'm at this point here, I'm at 0 in y and 1 in x, then the surface above is up there at 2. So I'll play connect the dots. And this is the prism we kind of want to find our volume for. We want to integrate across this this region, getting the height that comes out. So we're going to use our idea that we have an area that's being drawn out by these difference in functions. And so functionally, I'm going to look at my area over the region, or my volume over the region, is going to be some function of x and y times a differential in area. And what I'm going to do is I'm going to integrate from, let's see here, I'm going to go from here in my dy's, and I'm going to go from 0 to x, right? As I move across in y, my smallest y value is 0, and I make an element that's size x. So I guess for my y, I'll go from 0 to x, and then in my x components, we'll go from 0 to 1. So, right, this will be going from 0 out to x as I do a dy element, and all of my x components will go from 0 to 1 as we move across. So I want to then take my function of x and y, and then I did 0 to x first, so that was my dy, and then my dx. So I'll hold x constant, and I'll get 3y minus xy minus y squared over 2, evaluated from 0 to x. And so now I'm going to come back in, and wherever I see a y, I'm going to replace it with an x. So I'm going to get 3x minus x squared over 2. Whoops. Let me write that like a human being for a change. There we go. Let's see. Tried to undo, and I think I almost undid everything. So we have 3x, so x squared minus a half of x. This is, I'm going to be minus 3x squared. So 3x minus 3/2 x squared, sorry, dx. And so 3/2 x squared minus x cubed over 2, evaluated from 0 and 1. And so the zeros won't matter, so I'm going to get 3/2 minus 1/2, or 1. And so the volume of our prism is 1.